Hi students. So last session was on NFA and its conversion. Let's move on to discuss about another type of finite automata which is called as non-deterministic finite automata with epsilon transitions. In short, we call it as Epsilon NFA. So Epsilon NFA is very much required whenever we try to convert a regular expression to finite automata. Anyhow, regular expression to be discussed in further class sessions. As of now, let's understand what is epsilon NFA, how does it work, what is epsilon closure. Next session we talk about how do I convert epsilon NFA to DFA. So as the name says, epsilon NFA is an NFA. As the name says, it is FA there. So an automata, a finite automata with epsilon transitions. That's it. The question would be there, what is epsilon transitions? Please do understand, when there are two states, say for example, let's draw the state. Let's draw to some states, let's draw. Say this is state 0 and this is state 1. See, there is a transition from the state 0 to 1. Normally we write A. But remember, in the state 0, without giving any input symbol, the automata will be in the state 0. That is, there is a transitions with epsilon symbols we say. Please do understand, when I use the word epsilon, that means zero number of symbols or there are no symbols. Whenever there is a transition but there are no input symbol, that is termed as epsilon transition. And an FA which has or which consists this transition is called as epsilon NFA. So now remember one thing, in any state by default you'll have epsilon transition. You need to explicitly specify that, not required, but it can be understood by default. But on the other end, if there is a transition between the now just check it out. If there is a transition from the state 0 to 1 with epsilon, first question, can it be there? I say yes, it can be there. Second question, at what situations you get it? What are the scenarios you get it? As I said, uh, we deal with epsilon NFAs whenever we are writing FA from regular expressions. There is a topic called as regular expression to finite automata. In that, we try to discuss about it. Anyhow, at this moment, do understand, there can be a transition from one to another state without input symbol. This already I've cleared in my earlier sessions of automata. You can just check out those videos as well. Moving on. Now, observe this, 0 is initial state, 1 is final state. Without accepting any symbol, I have reached final state. Can I say symbol is accepted? Yes, definitely. Epsilon is accepted there. Remember, some of the DFAs we were saying initial state itself as a final state. Why? Because epsilon was accepting that. So keeping all these things in mind, definitely you can have a transition without any input symbol. Say suppose you have one more state now. Now let's say you have a transition like this. From the state 0 with the input symbol we have reached 2. From 2 we have reached final state with epsilon. Now remember, I say A is accepted, epsilon is accepted and A is accepted. Now if I make some self loop here, say B, I say D is accepted. I say that this FA accepts symbols A any number of p's. So this is just to give an example. Now coming back to the definition of it, definition would remain almost same with respect to NFA. Even this also has a 0, 1 or more transitions for any input symbol in any state. So no need to worry about that part. That would remain still same. So I say there exists 0, 1 or more transitions for any input symbol in any state. This would remain same. So as specified here, there can exist 0, 1 or more transitions. That's fine. Now how do I define formally? We know already, since I said it is as similar to NFA, so we just define it very easily. So formal definition of epsilon NFA. So it is same. It is a 5 tuple system. M equals Q sigma delta Q naught F. So this would remain same. Please remember, this should be known to you at any point of time, whether it is definition of DFA, NFA, Epsilon NFA. At any point of time, somebody asks, maybe in your examination or in your interview process and all, that should be in your tip of your tongue. DFA is a 5 tuple system. M is equal to Q sigma delta Q naught F. That should be always in your mind. So anyhow, we know already Q is set of finite set of internal states. Sigma is a finite set of external input symbols. Delta is the transition function. Q naught is initial state. F is finite set of final state, that is known. So as we should also define what is delta here. So delta would be, it is Q cross sigma union epsilon. So that would give rise to 2 power Q. So only difference is this now. So it is a Q cross sigma union with epsilon. So this is what we should worry about it now. So this is the only thing we should observe properly if it is epsilon NFA. Hope you could able to see this. So check out properly. Delta, the transition function is it has only two tuples, Q and sigma, but we try to consider epsilon also as an input symbol, as it is epsilon NFA. Moving on, we need to worry about how do I convert this to DFA. Even this is pretty much flexible to draw, but anyhow it is not efficient, so we try to go for what do we call it as converting this to a DFA. In order to do that, we need to remember one more thing called as epsilon closure. So let's understand what is epsilon closure. So epsilon closure is, it is set of all the states which are reachable from epsilon only. It is set of all the states. So there are two rules. Definition, or we can define it like this, or I put it like this. Formal definition of epsilon closure. It says epsilon closure of Q is defined as follows. Let's define it. First condition says epsilon closure for Q is Q itself. That is, what does it mean? Do understand. Already I explained it here. In any state without input symbol epsilon, mean to say without showing explicitly the transition with the input symbol epsilon, the automata will be in the same state. So no need to worry about it. That means by default, in any state, you will have epsilon transitions to itself. So we say epsilon closure for that state is that state. That is the first rule. Second rule says transition. If there is an epsilon transition from the state Q to P, then epsilon closure of Q is P. I can write it like this also, that is epsilon closure of Q will be equal to Q and P. Observe the second rule properly. If there is epsilon transition from state Q to P, that means whichever state we are considering, you just check the state. If there is any transition to any other state with only epsilon, in that case you say epsilon closure for Q is P also. So now Q is P. So now we have you should apply this rule number 2. Keep moving on. That means if there is a transition from Q to P with epsilon, you include P. Then check whether from P you have any other transition to some other state with epsilon. Include that. It keep on moving until you don't find any other state. So this part should be very much clear. So epsilon closure for that state is that state itself. And if there is any transition from one state to another state with epsilon, you should include that also as a closure for that. Now let's take an example. Take this. Find the epsilon closure for the following epsilon NFA. Now I should write this. Check out here. Q0 with A, Q0 with epsilon is Q1, Q1 with B is Q2. Some transitions are given here. Don't worry about the working of this automata, not required. Let's write epsilon closure. So epsilon closure of Q0. Check out how do I write epsilon closure of Q0. Epsilon closure of Q0, as per first rule, you just write Q0 itself. Then check where all we can reach. From the state Q0 with epsilon, we can reach Q1. So write Q1. Then from Q1, we can reach Q3. So write Q3. So epsilon closure of Q0 is Q0, Q1, Q3. To put comma because since we say it is set of states, it is very much required when you convert it into DFA. Now, let's check the next one. We should write epsilon closure for all the states. This also may be asked explicitly in the examination, sometimes even in your competitive exams also. So please pay attention. This is also required to convert from epsilon NFA to DFA. Epsilon closure of Q1. By default Q1, we should write Q1, don't forget that. Then Q1, and since you have a transition from Q1 with epsilon to the state Q3, we include Q3 also. I think that's clear. Similarly, epsilon closure of Q2. Epsilon closure of Q2 is Q2 by default. See, there is a transition from Q2 to Q1 back to Q1, so it should include Q1. Again, there is a transition from Q1 to Q3. So these three are the epsilon closure states for the state Q2. Similarly, last it is Q3. So epsilon closure for Q3 is Q3 itself. Hope that's clear. So epsilon closure for Q0 is Q0, Q1, Q3 because you have a transition C. We cannot write Q2 with for Q0 because there is no transition from Q1 to Q2 with epsilon. So we cannot. But remember, for the state Q2, the epsilon closure would be Q2, Q1, Q3 because there is a transition back. Please do observe. Hope this is clear. Let's take one more example. Check this. So let's find epsilon closure for this big diagram. Seems to be very lengthy, but pretty much easy. So let's start writing it. Epsilon closure for Q0 is Q0 itself. No more states because there is no transition from Q0 with epsilon to any other state. Moving on, epsilon closure for Q1 is Q1, Q2. That's clear. Similarly, try finding epsilon closure for Q2. It's Q2 itself. It's Q2 itself. Then epsilon closure for Q3 is Q3, Q4. Check out. We can reach from Q3 to Q4. We can reach anyhow. I have made it as Q0, Q1, Q2, but it is 0, 1, 2, 3, 4. That's okay, not an issue. So Q3 with epsilon is Q4. No issues. Q4 with epsilon is Q5. So Q5. Observe again. Q4 with epsilon is Q7. Then Q3 with epsilon is Q10 also. So you should write all those. So it is Q3, Q4, Q5, Q7, and Q10. Similarly, for the state Q4, it is Q4, Q5, Q4, Q5, Q7. Hope that's clear. So you cannot go further. Moving on, we just write epsilon closure for Q5. Epsilon closure for Q5 is Q5 itself. Only Q5, you cannot go further. Then check out epsilon closure for Q6. Epsilon closure for Q6 is pretty much important to check it out. Q6 is initial. Then check it is Q9, Q9, Q9. Then check from Q9 we can reach Q10. Then we can come back to Q3. So you should include Q3 also. Then again we can reach Q4, Q4, Q5, Q7. Stop it. Hope that is interesting there. So for the state Q6, it is Q6, Q9, back to Q3, Q4, and then Q5, and then Q7. From here you can say it is Q10, or from here you can say it is Q1, Q10. Then Q7 is Q7 itself. Only Q7 because you can't go anywhere. Moving on, epsilon closure for Q8 is Q8, Q9, Q10, Q3 coming back, same thing. Q9, Q10, Q8 coming back, it is Q3, Q4, Q7. So it is Q8, Q9, Q10. So going back, it's Q3, Q4, Q5, and Q7. So Q5, Q5, and Q7. Then epsilon closure of Q9. Epsilon closure for Q9 is Q9, Q3, Q4, Q5, Q7, and Q10. On the other hand, at the end, we can say epsilon closure for Q10 is only Q10 because we don't have any other states there. Hope that's clear. So you can easily write it. Observe properly once again. You should only check for this part going back, and remember, for any state you should have that state itself. There is a common thing, or blindly you can write, if you say epsilon closure for any state is that state, so I can say there is at least one state in epsilon closure. It can't be null. So do remember that. Hope that's clear. Epsilon NFA. How do I understand that? Epsilon closure to solve. Next session we talk about how do I convert epsilon NFA to DFA. Thank you for watching. Subscribe the channel, share it with your friends, click the bell icon for the subscription and for the notification. Thank you very much.